So the title of this project is Novel Isolated Power Conditioning Unit for Micro Wind Turbine Application. So for the turbine over here we used a model prototype of a wind turbine, and this is our converter. So this is the coupled inductor over here. So this is the quasi with the coupled inductor arrangement, and this is our inverter, where this is our multi-level inverter which produces a level of 5 level. So this is the MOSFET switch, which is of bidirectional switch with the 4 diodes over here, our multi-level setup. And this is the input. This is the microcontroller, which is of PIC16F877A. So we are using a 12 volt transformer over here, which is used to step down 230 volt to 12 volt, and this 12 volt has been passed to this board, microcontroller board, where it contains a voltage regulator which regulates 12 volt to 5 volt, and this 5 volt has been passed to microcontroller as well as the buffer circuit. Due to the 40-pin configuration of the microcontroller, when the current from the transformer passed to the microcontroller, it gets splitted up. So the output current from the microcontroller will be very less. In order to amplify it, we are using a buffer amplifier over here. So this is an optocoupler which is of 8-pin opto. So this opto is used to trigger these two particular switches over here, and this is a supply board for the opto, and this is the gate driver which is a fan 7392N which triggers two switches over here. This is our MOSFET switches with a heat sink, and the purpose of opto is it reaches the 12 volt to the MOSFET. The MOSFET switches conduct only when it reaches 12 volt. In order to reach the 12 volt, we are using opto for the particular switches over here, because they are of separate switches, so separate optos are over here. But in case of inverter, we are using a gate driver which can trigger two switches, and this is a supply board where a 12 volt DC supply has been given to the opto, and this is the area to measure the inverter multi-level output, and this is the separate grid line. Further, we take the project and making issues solved in the grid line problems. So this is a grid line, this is the input of a 12 volt transformer. So here we measure the voltages over here, and this is the potentiometer part which can vary. When I vary this at initial condition, my LED will be glowing very bright. When I turn on, when I vary this part even more, and I can show the condition of sag voltage, which may be of LED very dim. And from the multi-level output, so this is the wire output from the multi-level inverter. When I inject this to the line, this acts as a compensation, and our circuit get compensated. So now let us turn on the kit. So the circuit has been turned on. So supply from the wind has been generated to the circuit. And now let us measure this in DSO of 5 level output. I have connected the probe of a DSO over here. So the 5 level output in the DSO. Now I am connecting this probe to the line, grid line. So at initial condition, my LED glows so bright enough. So at a bright enough condition, at a full condition of voltage, you could see the input AC voltage. And now on vary the part, you could see the LED goes so dim. So now the voltage has been sagged, and the sag voltage in DSO. And in order to compensate this, I am using this multi-level wire to compensation purpose. So when I inject this to the line, so my compensation happens. So you could see the compensation. So injecting it here, so compensation happens. So the compensation voltage level inverter output is coming here for the compensation. So thank you for watching the video.